The graph of an inequality consists of a boundary line and a shaded region. If we're just graphing an equation, the points that are the solutions to the equation are just along the length of the line. But in the case of an inequality, the line is just the boundary that divides the parts of the coordinate plane that are solutions and are not solutions of that inequality. So to graph, we're going to start by just treating it like a regular equation. I'm going to pretend like it's y equals negative x plus 4. And so I need the slope and I need the y-intercept to be able to graph that line. So my slope is negative 1 in this case, or negative 1 over 1 for slope form. And then b is 4. So I'm going to go up to 4 for my y-intercept. And then from there I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, up 1, back 1 to generate the points that are going to make up my line. Now at this point I need to pause for a second. And so to start off with, because I have an equal to as part of my inequality symbol, I know that the points on my line are going to be solutions. So for that reason, I'm going to make the line solid. On the second example, we can see that the inequality symbol is missing the equal to, which means when we eventually graph that line, we are not going to have those points be solutions, so we'll represent that with a dotted line, but we'll get there in just a second. So in this case, I have a solid line, but now I need to figure out what side of the line are the points that work in the inequality besides the points that are on the line itself. And so the easiest way to figure that out is to plug in a point and test it. And so the easiest point to plug in is the point 0, 0. So I'm going to plug 0, 0 into my inequality and check to see if it makes a true statement or not. So 0 in place of y is greater than or equal to negative 1 times 0 is 0 plus 4. So we end up with 0 is greater than or equal to 4. Clearly, that is a false statement. That is not true. So what that tells us is the points that are on the side of the line where 0, 0 is located are not solutions in this inequality. Instead, the points that are on the other side of the line are the solutions. And so I'm going to shade on that side of the line to represent the points that work in this inequality. The second example isn't a linear inequality. Hopefully we recognize this as being the equation of a parabola, but that doesn't change anything in any meaningful sense for us. We still have to graph the line, and then we'll have to determine what side of the line are the points that work in the inequality. So we know that this is going to be a parabola. We know it's going to be upside down. So hopefully we can piece together that the graph of this parabola is going to have a vertex at 6. So I'm going to go up to 6, put a dot there, and it's going to go down because of the negative in front of the x squared. But there's not going to be any kind of dilation, no stretch or shrink or anything like that. So I'm going to use my usual pattern to plot out the points. I'm going to go to the left and right 1 and down 1, to the left and right 2 from the vertex and down 4, to the left and right 3 from the vertex and down 9. So that gives me a collection of points that I can use to get my boundary line. Now again, as I mentioned already, because there's no equal to, I'm going to make a dotted line because the points that are on this line do not work in the inequality, and so that's the way that we're going to represent that. It's very similar to the idea of if I have x is greater than 3 and I graph it on a number line, I put an open circle at 3 to represent that that point does not work, but then if it had an equal to, I would fill in the circle. So think of it as with the equal to here, I have the solid line, the filled in circle. Without the equal to in my inequality, I have the open circle or the dotted line on my graph. And so now once again, I have to determine which side of the line to shade on. Do I shade inside of my parabola in this case or on the outside? And so I'm again going to use the point 0, 0. I think that's the easiest point to use, and as long as my graph doesn't go through 0, 0, I can always use it. So if I plug in 0, 0, I get 0 is less than 0 squared is just 0 plus 6. So 0 is less than 6. And so this time I get a true statement, which means that 0, 0 is in the region of points that work in this inequality, and so I'm going to shade on the inside of this parabola here. Now there is a shortcut that we can use to determine which side of the line to shade. And as long as y is isolated and on the left, let's do a little erasing here to clean up. As long as y is isolated and on the left-hand side of my inequality, then I can just look at the inequality symbol and say, if it's greater than or equal to, I'm going to end up shading above the line, which is what we did here on this first one. Y is greater than or equal to negative x plus 4. Well, I'm going to shade on the upper side above the line. In the second example, y was less than negative x squared plus 6. So therefore, I shaded below the line, and so underneath this dotted line is this space in here. So that sometimes can be a little bit confusing, especially for nonlinear examples. So you can always default to the test of the point 0, 0. But this is a shortcut that we can deploy for determining where to shade in some circumstances.